The second part of 4.5 deals with the rational root theorem, and then we will get into solving or being given the solutions and then writing it as a function. Okay, it'll tell us what our a value is, or how many solutions we should have, if any of them are double roots or things like that. So the first part is the rational root theorem. Rational root theorem will go with the fundamental theorem of algebra, which we'll talk about tomorrow. Okay? So whenever we have the rational root theorem, basically it says no matter how many powers you have, whatever your highest degree is, basically that it's going to count backwards from that highest power. Okay? Just like we've talked about with division, like if your highest degree is 4, okay, then it's going to go x to the third power, x to the second power, x to the first power, and then x to the 0, which is just your constant. Okay, that your coefficients are integers, so that means they can be a positive or a negative counting number. Then what that means is that every rational solution, okay, has the following form. Basically, it can be a 0. Okay, it's basically what you're trying to do is find all of the possibilities that you can have. So we're not really going to find the real solutions. We're going to find all possibilities is what we're doing here. Okay. We'll solve everything tomorrow. Okay, so whenever we find all of our possible zeros, what we're going to do is you have basically two parts that we really care about. Okay, the only two parts that we care about is the very first term and the very last term. Okay, and what we can do is we can write all the possible zeros, rational zeros, okay, using those two numbers. Everything else doesn't matter. Okay, everything else in the middle has no bearing. Everything else in the middle basically matters to what happens in the middle, like how it turns and when it goes up and when it goes down, or how steep our curve is, things like that. Okay, the numbers on the ends, my constant and my lead coefficient, essentially, is what's going to determine where it crosses the x-axis. Okay, and if it crosses at a rational value. So remember, a rational value is any sort of counting number, any number that is going to, any decimal that is going to repeat or terminate. Okay, so like if it was 2/3, 2/3 would be an option. Okay, and you'll understand why we do that later. So what I want to do first is, if the p, it's just p over q. I'm just going to set this up as a fraction. Okay, the first thing I want to do is I want to find all my factors of my constant term. Okay, so my constant term is the one that is circled in orange. So what are all of the factors? Okay, so p. What are all the factors of 20? What numbers can multiply together to give me 20? 1 and 20. What else? 2 and 10. 4 and 5, right? Now, with this, okay, I'm not just going to have all positive values. Okay? Because what if I multiply -1 and -20 together? Do I get a positive 20? Yeah. Okay? So whenever I write this, I always want to write this as plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, and then plus or minus 20. Or just write it in order. So as far as the possibilities, you will always have a plus or a minus value. Because regardless, even if it's a negative, I can still take a positive and a negative number and multiply those together to get a negative constant value. the second part of this then is my Q. Okay? So Q, what is my lead coefficient? What is the number in front of x squared? 1. What are all my factors of 1? 1. Plus positive 1, negative 1. Now, you can do this a couple different ways. Okay? Usually what I do is I kind of shorten everything up, but I'm going to show you the long way first, and then I'll show you the short way second. Okay? So I have all of my numbers of P. I have all of my numbers of Q. Okay? All of my factors. So now all I'm going to do is I'm going to take each one of my values of P, and I'm going to divide it by each value of Q. So what is 1 divided by 1? Okay. So again, since it's positive and negative, okay, I can just write my possibilities of plus or minus 1. What if I do the same thing? What is 2 divided by 1? 2. So plus or minus 2. What is 4 divided by 1? 4. What is 5 divided by 1? 5. What is 20 divided by 1? 20. What did I just do? Okay, I divided, yes. What else did I do? Did I rewrite a list that I already have? Yeah, what list? P. Okay? Regardless of whatever your factors are, I'm not really worried about my factors of Q just yet. Okay? If it's just 1, the whole list is predicated on the factors of P. You will always have all of the values, whether it's plus or minus 1, plus or minus 2, plus or minus 4, 5, and 20. You will always have those numbers in your list. Okay? So what I would tell you is not so much to rewrite your list of P, is just to add on to it later. Hayden, question. Sorry about that. I forgot the 10 whenever we talked about it. That helps. Now we have all the options. So whenever you have your list for your constant of all the factors, you will always have that list, and then you would add to it. Now, I don't have another value for Q. Okay? I don't have another factor of my lead coefficient. So there's nothing else that I'm going to add to basically my original list that I had right here. Okay, if there's no factors of my lead coefficient, if it's just 1, then the only possible outcomes that I have are the factors of 20. Okay. Now, same thing. I'm not going to find all the real zeros. I'm just going to find the all possibilities or all possible zeros from f of x equal to 10x to the 4th minus 11x to the 3rd minus 42x squared plus 7x plus 12. P is 12, right? What are all of my factors of 12? 1, 2, 3, 4, and 6. So what do I know? Before I even have my list, I know what values are automatically going to be in my list of all possible zeros. Those numbers right there, right? Whatever the factors of your constant are, they are automatically possible zeros. Now, I want to do the same thing, but I'm going to do it for Q. What are all of my possible zeros, or excuse me, all of my possible factors for 10? 1, 2, 5, and 10. Now, here is where I would shorten everything up. Okay, because I don't want to waste my time just rewriting 1, 2, 3, 4, and 6 again. And 12. Man, I'm on the struggle bus today, aren't I? There we go.
It was the same, and he has a pen. It was
So instead of writing all of my factors of 12, instead of writing 1, 2, 3, 4, 6, and 12 again, okay, I'm just going to add to that list that's already up there, that's already in black. Okay? I don't need to take 1 and divide it by 1 again. I don't need to take 2 and divide it by 1, 3 divided by 4, 4 divided by 1, 6, and 12. I'm just going to go to the next number, and what I'm going to do is I'm going to add to the list that's there in black. So I'm going to take, what is 1 divided by 2? I'm going to take 1, and I'm going to divide everything by the numbers in my list here. So what's 1 divided by 2? 1/2, right? What is 1 divided by 5? 1/5. What is 1 divided by 10? 1/10. Now I'm going to do the same thing, but I'm going to do it with the 2. I'm going to take 2 and I'm going to divide it by every single value down here. We already did 2 divided by 1. We already have 2 in my list. If I take 2 divided by 2, do I need to rewrite 1? No, why not? Because it's already there. It's already written in black. 2 divided by 5, do I have 2 over 5? No. So, plus or minus 2/5. Do the same thing and take 2 and divide it by 10. Do I have 2 over 10 in my list? Yeah, I already have 1/5, so do I need to write that again? No. If you already have a number, go ahead and simplify it. There's no need to write 1/5 and 2/10 because they're the exact same thing. That's just a waste of your time whenever you can be adding to this and not spending more time than you need. So I'm going to do the same thing, but now I'm going to do it with the 3. So with the 3, I'm going to take 3, I'm going to divide it by 1. Do I need to add that number to my list? No, because I already have it. What about 3 divided by 2? Do I have 3 over 2 in my list? Nope. So 3/2. Do I have 3 over 5 in my list? No. So plus or minus 3 over 5. Do I have 3 over 10? Nope. So 3/10. What do you think the next step's going to be? do the same thing with the 4. How about we just go with the next number in my list? So 4 divided by 1, do I need to add it to my list? Nope, it's already there. What about 4 divided by 2? Nope, it's already in my list because I have 2. What about 4 divided by 5? Huh? Nope, I need to add it, right? So plus or minus 4 over 5. What about 4 divided by 10? Already have it with the 2/5, right? So in some cases, you're not going to have to add a whole lot from one thing to the next. Do it again then with the 6. So do I need to add 6 divided by 1 to my list? Nope, it's already there. What about 6 divided by 2? Nope, 3 is already there. What about 6 divided by 5? Yeah, I need to add that to my list. So plus or minus 6 over 5. What about 6 over 10? No, it's there with the 3/5, right? And then lastly, go with the 12. Take the 12. Do I need to add 12 divided by 1? No, it's already there. Do I need to add 12 divided by 2? Nope, it's still there. That's the 6. 12 divided by 5. Go ahead and add it. And then 12 divided by 10. It's already there with the 6 over 5. So it doesn't matter to me how you do it, as far as if you want to just go through your list, and I'll have some students that will basically take the 2 and divided by 2, the 3, and they'll just kind of run through their list and kind of go with the bottom. Okay, I would say just go with the 1 and divide everything. So 1 divided by 1, 1 divided by 2, 1 divided by 5, 1 divided by 10. Kind of like how I did it in the blue, the orange, the green, and kind of color-coded it there. Okay, but again, I'll have some students that will just take the 1 and divide it by 1, the 2, and kind of go with the top and hit each factor of my Q. But as far as the possibilities, these are all of the possible zeros that I have that my graph could cross. Now, is it going to cross every single one? No. But these are all the possibilities, okay, to figure out when it is at 0. Now, tomorrow, when we get into it, we'll actually use the list, but right now you're just trying to find the possibilities. Okay? Some lists are longer than others. Some are really short. Some are really long, like this one here. Okay? Now, the second part is when we are going to write a polynomial function of least degree that has a rational coefficient. Okay? Now, one thing that I want you to do is, instead of having, so you have a 0 of 2, just make this a 0 of square root of 5. Okay, it'll be a little bit easier to kind of break you in a little bit. Now, with any of these, whenever we write our function, my fault, we always want to take, whenever we start, okay, we always want to take the 0 and set it equal to x minus whatever number we have. Okay, and x minus whatever number we have. Because whenever we change it, if it's a plus, okay, that's really just taking the opposite. Every problem always starts out, if we're given a solution, it's always going to start out as x minus and then a value. Okay? What changes it to a positive is if we have a negative value. Okay? So what that means is, if I have x minus a number, well, what are my zeros? Okay, my first 0 is at 3, so all I'm going to do is I'm going to take x minus 3. If the second value is the square root of 5, what is x minus the square root of 5? Let's have that there. Now, what do you know about all square roots? They always have a positive and a negative. So if I have a x minus a negative square root of 5, what do these two negatives actually do? It turns it into the positive that we have. So all I do from here is just take x minus 3, x minus the square root of 5, and x plus the square root of 5, and I multiply everything together. Now, what I would suggest is anytime you have a square root of any sort, to multiply those first, because they're going to be conjugates of each other. What's going to happen? The middle's going to go away, right? Okay, so I wouldn't do anything with the x minus 3 until the very end. So if I multiply x minus the square root of 5 times x plus the square root of 5, I'm just going to rewrite the x minus 3. What's x times x? X squared. What's going to happen with the x times the square root of 5 and x times the negative square root of 5? What's going to happen in the middle? If you're not sure, just multiply it. So x times the square root of 5 minus x times the square root of 5. What's going to happen right there? They're going to go away. What's the negative square root of 5 times the positive square root of 5? Negative and positive are negative. What's the square root of 5 times the square root of 5? Square root of 25. What's the square root of 25? 5. So really all this boils down to is x minus 3 times x squared minus 5. What do I need to do now? What's x times x squared? X to the third. X times negative 5 is negative 5x. Negative 3 times x squared is negative 3x squared. Negative 5 and negative 3 is a positive 15. Put everything in standard form. So that means put it in order. So I have x to the third minus 3x squared minus 5x plus 15. Always start out with x minus whatever your zeros are and then change them from there. It'll make things a heck of a lot easier. Okay, but remember, whenever you have any sort of square root, you're always going to have a positive square root and a negative square root. Okay, you're going to finish your assignment that was posted yesterday